Picking back up with this next equation, we've got 2 sine squared minus 3 sine of theta plus 1 equals 0. In addition, we also have some restrictions on our angles. We're only going to go between 0 and 2 pi. What we should notice is that there's a sine raised to the first, there's also a sine raised to the second. If I were to let w equal sine of theta, you could quickly see a quadratic equation as a result. 2w squared minus 3w plus 1. This would factor, by the way, into 2w minus 1 and w minus 1. Setting these equal to 0, using the zero factor theorem, we'd see that w is equal to a half and w would equal 1. Now, if w is equal to a half, that's really saying that the sine of theta, what w is really equal to, is a half, and the sine of theta is going to equal a 1. Now, of course, in the unit circle, we have all students take calculus. Sine is positive in the first and in the second quadrants, with a reference angle of pi over 6. So we'd have theta is equal to pi over 6. We'd also have theta is equal to 5 pi over 6. Where is sine equal to 1? Well, I hope that's something you've memorized. The sine of pi over 2 is equal to 1. And we just circle all of these and we are good to go. As we look at our next problem, 3 cosine of theta plus 3 equals 2 sine squared, again with some angle boundaries, you're probably noticing that this is a very different problem in that you have cosine and sine involved here. To get around this, you want to always get down to an equation where you just have one trig function involved. The most famous trig identity is sine squared plus cosine squared is equal to 1. I could subtract a cosine squared from both sides to come up with sine squared is 1 minus cosine squared. I'm going to rewrite this problem using that identity. That instead of writing sine squared, I will say that's equivalent to 1 minus cosine squared. The reason, of course, is now I have only one trig function in this equation. As I distribute the 2 on the right, we'll get a 2 and then minus 2 cosine squared of theta. We can subtract a 2 and also add this 2 cosine squared of theta over here. And this is a positive 3 cosine. So we'll have 2 cosine squared of theta plus 3 cosine of theta. A 3 minus a 2 is just a 1. And then we're going to let w fill in for cosine. Just very similar to what we saw up above in the previous problem. This is really a quadratic. And it's a quadratic that we can factor. This would factor into 2w plus 1 and w plus 1. And then we can use that zero factor theorem, also known as the zero product property. And it would only take a moment to solve. You'd get w is equal to negative 1/2 and w equals negative 1. Now w, of course, was just temporarily filling in for what cosine of theta is equal to. So I have cosines equal to negative 1/2. I have cosines equal to negative 1. And where is cosine negative? Well, you can see it's in the second and in the third quadrants. Cosine would have a value of a half at pi over 3. So in the second quadrant, we'd have 2 pi over 3. And in the third quadrant, we'd be at 4 pi over 3. Cosine is negative 1 at pi radians. And here are your 3 answers that you will be working with. The last problem is actually just a very similar calculator problem. Make your left side equal y1. So we'll have 5 sine x plus x. Let's have our right side, y2, be a 3. And we're going to just make sure we're on the radian mode. And we are from earlier. Just takes a moment to get this typed in. Now, again, the window that you're looking at, I think is very, very important. I think sometimes when kids start off here, they might look at the window that we had previously. You know, sometimes kids only want to look between 0 and 2 pi, and that's not a bad place to start. And, you know, if we looked at this, we'd have a 3.1 to maybe negative 3.1. You can see we've got our sine of 5 sine x plus sine of x. Up here is y equals 3. I guess what I want to warn you about is this, that very often kids will say, oh, we've got the 3 answers here, and then it's periodic, so we'll have infinitely many solutions. The thing is, if you just looked at y equals x, that's a line that looks something like this. As you're adding a sine wave to that, I think it's very important for you to see that really, if we went up to say 10 here, you can begin to see that your sine wave can actually begin to grow. And, you know, even if we were to open this up a little bit, have our x max get a little bit bigger, maybe instead of going up to 2 pi, maybe you'd like to go up to just 10 radians and look at it from that perspective. So here's your sine wave, and you can see it's beginning to grow and rise up, you know, just like this line y equals x. Similarly, you could go from negative 10 and, you know, just see what happens there. You can see, you know, this sine wave is growing along the line y equals x. And, you know, as you are looking here, you can pretty much see there will only be 3 intersection points. Let's see if we could get them very fast. We'll go to our intersect tool. First curve is that trig function. Second function is the y equals 3. Here's our first answer. It looks like we'll be at 0.52. Let's see if we can get to our second solution real quickly. We'll go second, calculate, come down here to intersect. And we'll say first curve, well, we've got our trig curve right here. Second curve is right there. That's not even a bad place to guess. Looks like we're at 3.18. And we've got one last little thing to take a look at here. That final intersection is just a tiny bit over. And you can see if we are on this sine wave plus x, you can say that our final intersection sure looks like it's 5.71. By the way, if you're ever worried if maybe there is another intersection, I think that can always be a concern. You could begin to graph it out a little bit further. You could say, hey, what if instead of going up to x equals 10, what if I went up to, say, 15 or something like that? And, you know, just in case you're concerned with, hey, will that ever cross again? Well, no, you can see we had 1, 2, 3 different solutions. So we're going to have a quiz tomorrow, like we had mentioned before, on 7.1, 7.2. No calculator on that, just 10 questions. And tomorrow we'll actually have a second day on these trig equations. The homework is here on the bottom, page 465, 11 through 91, every other odd.